I'm Jon Magill. I always like to start all of my talks with two questions. I'm going to add a third one today. How many people are left-handed? Ooh, kind of low. How many people are west of the Mississippi? No. How many people live west of the Mississippi? Thank you for, okay. And then how many people are Mac users normally Mac users? Okay, thanks. Two hands counts, you have two Macs. I've been fascinated by getting curved surfaces in ornamental turning pretty much since I started ornamental turning. And along with that fascination and all the other things like simplifying ornamental turning with the MDF, I've always wanted to come up with and had a lot of different ideas about simplifying the notion of what a spherical slide rest is. Fortunately, my slides will be much shorter today because Fred gave half of my presentation earlier and told you all about spherical slide rests, so I don't really have to talk much about that now. But I will still. I got to start out with probably one of the biggest contributions to ornamental turning in my life is Gorst. He took a suitcase Rose engine to Pasadena in 2003 that I call the Holy Rose engine. And I think, Phil, do you have that now? And it's going to be in good hands and get restored? Or I don't know where it lives now.
It lives in the back of my trailer right now.
Oh, Brad, okay. So take good care. Okay. I don't want to get into a lot of personal stuff. Most people don't know a lot about my history, but I will say my favorite job of all time was when I was an evangelist at Apple. And an evangelist is somebody who basically is a zealot about going out and converting people to this thing that they have a passion about. I'm passionate about ornamental turning and always have been. And I had this epiphany, I don't know, a few weeks ago. I was trying to figure out what it was about the connection I had with Gorst, and then I realized that Gorst was really he's the evangelist for ornamental turning. The spherical slide rest really has, Gorst, I always say, or I like to say, he brought more organic flair to ornamental turning than just about anybody else. We see a lot of fantastic work in the other room, but Gorst had this notion of bringing organic shapes in, and whatever he could do to manifest that, he just did it and went off and did another thing. And through the years, it was, his work was always far, far more organic than most. These are what he called, at one point he named them Fred's Fruits. They were called pods. They had a bunch of different names. And they were very, a lot of people saw them, they took notice of them, made a magazine cover in Germany, the German wood turning magazine, but just a really cool organic shape. And most people just don't have an idea of how these were made because most people look at it and assume it's curvilinear, not spherical slide rest. This is a picture of one being cut on his machine. He applied just about every rosette possible to create these shapes and tried everything. The thing that I'm going to point out here that you'll see through the rest of the discussion and presentation and what I've done is notice that there's an arc that is a part of a sphere, in this case a whole sphere, and then there's a section that's curved, the reverse curve at the bottom of that, that's the radius of his cutting frame or the diameter of his cutting frame, whichever way you want to think about it. He took that shape that was on the lathe there, that turned into what he called the Personages series, and he gave a lot of these pairs to friends that he thought they resembled the spouse and the couple, but he made them by the boatload, so like everything, he was one of the most prolific turners probably on the face of the earth. Spherical slide rests, as Fred talked about earlier, come in various levels of complexity. I think this is an Evans. I got some, this might be an Evans. I got this slide from John Edwards, courtesy of him. This is a typical antique slide rest. It has all the drawbacks Fred talked about earlier. There's all this mechanism in the way of the thing you actually want to turn. This is a spiral spherical slide rest like the one Fred showed in the box earlier. This is just mounted on a lathe. Same idea, same basic idea, different design, but you can drive it, turn a spiral as you're driving through a spherical turn. This is the first one I ever saw, and it led to one of the ideas that I'm going to talk about today. I saw this at Ted Crom's shop, and the little device in the front is the piece that I think is missing from every spherical slide rest, and that thing drops into the slot in front of the tool holder and tells you where the pivot center of the spherical slide rest is. And most of the spherical slide rests don't give you a hint where that is, so most new users trying to set up one don't really have any idea where in space they are, and that's what I thought was most interesting about this one. I don't know the origin of this one. I suspect it was French, given the stuff that Ted had, but you know, it was too long ago and I can't ask Ted anymore. For those of you, most people in here I think know Jon Edwards, and Jon Edwards has a huge amount of stuff on his website under the craft where he walks you through all kinds of different things. And John's not here. His website's up at the top. If you're not familiar with him, ornamentalturning.co.uk, and if you're not familiar with him and you don't have your Holtzapfel Volume 6 yet, he's the producer of that. There's only a few copies left. But because John's not here, I can kind of make fun of him and say he published very precise, very British explanation of how to set up your spherical slide rest. Fortunately, nobody in this room really needs to follow these directions, but there's other ways to do it, but he's got very precise instructions up there. I've been fascinated, like I said, by spherical slide rests and cutting continuous curves on convex curves in particular, on a Rose engine for a long time. I did a AAW demo, I think this was from Richmond in like 2008. And what I cut here, this is a slide, I had to travel, so I had to make a travel lathe, and I always have ideas, and I always execute them like the week before going to the AAW in normal style. And this was a plastic slide rest. I made a pair of them because Bonnie and I did alternating demos. One person would set up and talk about what they were doing while the other person was turning. When ornamental turning, we always say it's about as exciting as watching paint dry. And so we just did dueling demos and had two of these running. But I cut a curved T-slot, and this thumb, where's my little pointer? This knurled thumb nut here goes down a T-bolt that goes down into this curved slot, and there's a pivot that's buried under the front of this slide rest. And so it was a way that I had to kind of play around with and experiment on the MDF lathe, probably almost 10 years ago now, with making smooth convex curves. That idea has been festering for a long time in my brain, and so John Moe, do you remember, was this in Scranton that I brought this? Yeah. So this is the original MDF kind of in the background, and this is just a plywood sled that sits on top of it. I brought it, it's over in the other room, and anybody that wants to see how it works, I'll be happy to sort of play with it and show you. But I wanted to show these slides because you'll see the evolution of the idea here. The lower sled here with the knob in front just slides back and forth using the front edge of the lathe as a guide. And then the sled that's on top of it, has this funny little knob here that I'm going to show some more pictures of, and that rides in a T-slot here. So that means and this is the pivot for the spherical slide rest. So you can slide it forward and back to create a pivot point, decide where your pivot point is. You slide the table back and forth to decide where the other X and Y axis of your pivot point is. And then in this case, I put a sort of a poor man's lead screw here that I'll talk about too, so that you could just sit there and crank it through the motion for the spherical slide rest. So here it is kind of broken down. There's the bottom sled, and you'll notice there's a 3/4 inch hole here and a 3/4 inch hole here. There's a view of the T-slot up close, and you can just see that's just a normal T-slot running across the width of the table. And then kind of an exploded view, what I did is in the T-slot, there's just a bolt that sits down in the T-slot, and it passes through a piece of a 3/4 16 bolt that I cut off and drilled a hole through the middle of. So that passes through there. And then this knurled knob screws onto that 3/4 16, and this 1/4 20 knob screws onto this. And the effect is, you can see this is passing through. This is now threaded down onto there with a knurled edge here that you can grab on. And then the knob, this knob goes on top of that. And what that does is it creates a pivot that now this knurled knob can clamp down on the plywood when the 3/4 inch hole is dropped onto that OD of that shaft. This clamps down with some pressure, and this knob now lets you loosen at any time, slide it where you want in this T-slot, and position and lock down your pivot. So incredibly easy for anybody in here to make in their own shop. And then I borrowed and cannibalized, if you've probably seen these before on drill presses and things like that. Sometimes they're called push button nuts, sometimes they're called speed nuts. It's a push button that's threaded partially on the inside. I don't have a good picture of that, but they're threaded partially on the inside. This is an original one. It's a hex nut. You can get them round or knurled or hex. There's a bunch of different varieties. McMaster-Carr probably sells a dozen different kinds in a dozen different sizes. But the push button, when you push it in against this spring, it disengages away from the thread on the threaded rod. I took the guts of one, and then I turned out of my favorite material, plastic. I bored a hole to receive the spring that drops down inside here, and then the push button part of this drops down until it's flush with the top of the nut. And so I basically have 2 speed nuts on this chunk of all thread. And what that lets me do is the speed nut at the end that I cannibalized and made my own drops into a hole here. So now that's engaged with the all thread at one side. And then at the other end, I just took a hand crank that you can buy, again, off the shelf from McMaster-Carr, stock part. That's on a post. And the other speed nut is here that's just acting to back up from this post is just drilled through. So now the hand crank's here. This nut's preventing it from, creating any backlash and sliding away. Now you have a hand crank that you can turn and crank this across the whole sled. So that's what the complete assembled thing looks like again. You've got the hand crank here to pull or push. You can drop this into this corner or the back corner of this sled. I made 2 legs here that are adjustable with these knobs that slide in or out so you can kind of get a reasonably tangential pull on the slide rest. And then the pivot is just positioned wherever you want. This is where the hardened slide rests. I took it off for clarity, and you can see it over in the other room exactly like this. There's 2 different legs you can put on one side or the other if you're pulling or pushing, and get kind of aligned for the cleanest line of sight for pulling across your bench. So I built this and brought it to Scranton a couple years ago, and my goal in life as an evangelist of OT is really to encourage people to take an idea, adapt it to whatever they're trying to do, and build something yourself. Because like when I started in ornamental turning, you could either find a dilapidated antique machine that you had to spend half your time doing restoration, and as Fred knows, I didn't get the restoration gene. So I'd much rather build something from scratch or buy something that's working so that I can get on with the act of making wood chips. So anyway, I encouraged my local gang up in Seattle, and I just put in a couple pictures here. Bob Sievers, one of our members up there. John built one, Tom built one, and Bob Sievers built one. This is Bob Sievers, and you can see it's the basic idea, but it's just adapted. He's using a piece of string to pull it through around an idler pulley that comes over here. He's got a clever clamping mechanism that's on a piece of all thread with a U-joint cannibalized from a Craftsman socket set that goes to this pulley. And the pulley is enormous in size and goes back to the headstock pulley. So he's got a slow speed drive that's driving and turning this all thread with this clever split nut that you can just basically unclamp the clamp, move it to anywhere you want on the all thread to take up the slack, and then put the clamp back on to get the force on the half nut, if you will. Here it is from the other side. You can see he's just turned some MDF pulleys. He's got a belt that goes on this huge one that goes through this socket universal joint and turns the all thread to swing through the arc. And here he is turning a 5-6 inch diameter piece. And Bob Sievers has macular degeneration in both eyes. He's blind as a bat, and he turns out more ornamental turning than anybody else, up in the Northwest anyway. So I don't ever stop thinking about problems. And the AAW, I was asked to do demonstrations at the AAW in Atlanta in June. And so I gave it a little more than a couple weeks this time, but I had a whole bunch of ideas, and I thought, okay, if I'm going to do the AAW demos, I may as well roll as many ideas as I can into one prototype lathe to just test out each of the ideas and see how they fly. And so I wanted to build another version of a simpler spherical slide rest. I'd played around with these other previous incarnations. I had some good ideas about what would work. And I knew from the one that I saw years and years and years ago at Ted Crom's that I had this idea for something that I called the visualizer. And I wanted to make it as easy as I did on the rosettes on the MDF for people to do phasing. I wanted it to be as easy to visualize what the curve would be that you would get, convex or concave, using a spherical slide rest, because I think that's the hardest thing for people to see. I have these, I'm going to pass them around. Any woodworkers around here probably have played with or seen these. I wanted to play with some mag switches, and so I wanted to put a steel tabletop on a lathe and see if I could make this work. So I'm going to talk about those in a second. I needed to build a travel or shippable lathe, so I was going to build it out of 80/20, which is the industrial erector set is what they call it if you're not familiar. But I wanted to build that out of 80/20. I've got a couple other projects in the queue that I'm going to use this aluminum extrusion for, so I thought, well, I'll start the experiment with this prototype lathe and see where it goes. David Lindow was generous enough to loan me a double eccentric dome chuck to use in the demos. And when I got the dome chuck, I said, crap, I don't have enough swing on my lathe to manage this. Solved with a gap bed lathe. So I modified the design on the fly and turned that into a gap bed lathe using the 80/20 as the sliding mechanism to move the bed back and forth. And then I wanted to put some GT2, GT3, which is it's a nomenclature now for timing belt, very low backlash or low slip timing belt design that replaces essentially, if you're familiar with XML and XL and MXL belting. So they're basically the modern replacements for those, available in a bunch of different pitches, but they're now used in all the high precision positioning type devices that are using stepper motors and servo motors on various motion controlled devices these days. And I needed a test bed for these IGUS extrusions that I'll tell you about and you'll see in pictures. And I wanted to use some anti-backlash nuts that I'd sourced, and I needed an experimental platform to do some of the stuff I'm doing with stepper motors. So I rolled it all into one machine and spent a bunch of time preparing for it. But this is the thing I wanted to talk about today, and you'll see pictures of the other stuff as I go through what was just on my laundry list to roll into this one lathe. This is what I call the simple spherical slide rest, and I'll break it down in a bunch of details now. So first and foremost is this attachment, which you'll see in a few more slides, and I'll talk about it. It's what I call the visualizer, and it's just a piece of clear perspex or plexiglass that I mount on a rod that comes up out of the end of the lathe, and you'll see that in pictures, how that works to accomplish what I wanted to do to make this simple. The mag switches that I'm passing around, I bought a bunch of different sizes. You can get these in the woodworking world, they're used mostly on things like table saw fences and feather boards and things like that. And they're available in a whole bunch of different sizes because they use them in commercial and industrial applications for lifting and everything else. They just have a little switch on the top. You turn it 90 degrees to turn it on, turn it 90 degrees to turn it off. The one that I'm passing around right now is this smaller size number 60. The one that I ended up using on the slide rest is a number 95, and I used two of them on each of these slide rests. I made an XY slide rest and I made the spherical slide rest. And it turns out that the combination that worked for what I wanted to do by intuitive engineering was the number 95, two of those, and I had to use 20 gauge steel. So for reasons nobody cares about, the magnetic flux that has to flow through the steel for these magnets to work, it turned out I couldn't get it to work reliably with anything less than 20 gauge. And if you have a 1/4 inch plate steel, that I've now made a plate that sits on top of the bed of my Mark II so that I can do these same things. And so if you go to thicker, it's even better. It holds much, much more stronger. But on 20 gauge or thicker, these magnets are just, they're the cat's meow. I started out with I took a piece of Baltic birch plywood, 3/4 inch Baltic birch, and I just contact cemented on this 20 gauge piece of steel. It was flat enough. I had sort of sanded and cleaned it. And then after I did that, I countersunk some holes so that I could go in and attach the tabletop to the 80/20 material that I'm using for this portable prototyping idea testing lathe. And because of the spherical slide rest, this table is asymmetric. I've got more room right now in the back area because I know for most convex cuts with a spherical slide rest, I'm going to end up having the pivot somewhere back here. The bed slides here with these two knobs. I can just slide this bed anywhere I want. And so I kind of get the double whammy there with the real estate back here and then the ability to slide it farther out when I need to be farther away from the headstock to accomplish the full radius cut. But because the spherical slide rest sometimes needs to have the pivot out in front if you're going to do a concave cut, I can just take this whole table, just slide it right off the end, flip it around, and I get the real estate on the other side. The bigger one at home, I just built it with a bigger piece of steel, but for this travel lathe, this chunk of steel fits in a suitcase, and I can kind of almost take this through TSA without alarming them. This is 80/20. 80/20, they call it the industrial erector set. There's a jillion sizes. You can get it, anodized or not, and metric or SAE dimensions. The stuff that I used it's an 1.5 inches by 3 inches. The metric stuff is what I'll probably use for the next projects that I do, only because the fasteners are kind of more interchangeable, the stuff I'm doing. But they have inch series and metric series and up to enormous cross sections. This stuff is very stiff, very dimensionally accurate. You can use it for all kinds of things. They sell linear guides that work with it. There's every accessory under the sun. They make cabinets for protecting equipment and other things in industrial applications. It's just, if you get hold of the catalog or go to the web page, it's mind-boggling. And then on the MDF lathe, I took, because I'm kind of working on stuff with stepper motors, and I knew I needed to use these GT2, GT3 belts, I decided I'd cut my own pulley. So I took a piece of my favorite 3/4 inch thick high-density polyethylene, HDPE, and I just machined that tooth profile for the GT2, GT3 5mm pitch belt I picked a tooth number that would fall down below the OD of my rosettes with the belt clearance, and so that turns out to be 108, which turns out to be a good number for working with a lot of the things even the British liked as divisors and factors. And in this one that's in the other room right now, although I had it driven with a stepper motor, it's currently driven with just a gear motor because of David's enormous dome chuck. The stepper motor on the first try couldn't turn the dome chuck, so I reverted to the gear motor and went to the AAW, and I pretty much haven't done anything other than house stuff since then. But the other beauty of these particular profiles is that they're easily machinable on a milling machine, and there's software that generates the tooth profile. So for even enormous size pulleys, you can do these very, very easily from top-down machining. I got fascinated through another project with this, what they call IGUS Drylin W twin rail, and it's a extruded aluminum product that's coated with a tough ceramic anodizing type coating. The one beauty of it is the rails, because it's all monolithic. This is the profile of it here and the size I used. It's 40 millimeters across, and it has the two rails, which are here and here, are guaranteed parallel because they came out of this just highly accurate extrusion machine, and they're just really nice. The ceramic coating they put on them, they then sell these little trucks or cars that you can then bolt onto whatever you've machined and designed. And these theoretically run, very low friction and very, very accurately on the rails. I'm not terribly pleased with these right now, but I may be won over. I may go another direction. Anyway, here's the XY slide that I built for the symposium doing the same thing. 2 of the mag switches, the bottom layer of the slide rest going the one way, the top layer going the other way. I have anti-backlash nuts inside here and just fancy ornamentally turned knobs to use it as a demo machine. This isn't a high mileage slide rest, it was a test bed to do some things. These you can't see in the picture, but if you're curious, I'll show you in the other room. There's 2 of the cars on this slide rest because I had a lot of play between the stages. The cars or trucks on this side actually have a little Allen screw that allows me to adjust them and take out some of the play, but it's still not perfect to the degree I'd like it to be for the accuracy of what we're trying to do. For the spherical slide rest, I created what I call the puck and ring. From an engineering standpoint, having the largest possible bearing surface for the rotational area of the spherical slide rest makes it accurate and low friction. And so as I was thinking through the problem, I said, well, if I took 2 of these magnets, which I knew I had to have to hold everything down, that kind of forced my OD of this puck, as I call it. And I realized once I got to that size, I was going to end up with a little bit of space in the middle. And that turned out to be exactly what I needed to mount this 3/8 rod. So I could drop the 3/8 rod down in there when I need it and then pop it out when I don't. And then I milled a shoulder halfway down on the puck, and I made the ring half the height of this 3/4 inch support that is the bottom of the whole slide rest. And if you look at the bottom of the puck, I can pass this around. Good catch. Sorry. Thank you, Charles. The bottom of the puck, basically, the magnets have to be exposed through the bottom, and they're designed to work, the ones that they sell here in this series are designed to work with 3/4 inch thick material, which happens to be the plastic I chose. And so these basically just touch the steel. I gave the allowance on the shoulder height so that the whole arrangement could swivel. So here's that assembly snapped down and locked on. If you haven't seen it in the other room, here it is in a slide form. And then as I said earlier, Fred gave half my presentation this morning so I can whiz through this. But whenever you're using a spherical slide rest, I don't care, I don't know, I'll just say in my experience, you have to do something for a spindle extension. It almost always ends up, you're trying to swing into an area you can't get to without some sort of spindle extension. And so I just have a normal, there's a lot of aftermarket 1'8" spindle extensions. And then what I've been doing a lot is I take one of these, they call them a bottle stopper chuck. And it's threaded 1'8" female on the inside and 3/8/16 on the outboard side. And for all of my demos and things now, I just take my standard hard maple that I use for the demos. I drill and tap that 3/8/16, and depending on what the wood's like, I'll either put CA glue in there or a little wax, and then that just threads right on here, and I'm ready to go. So when the blank is on that mandrel or chuck, and the slide rest is snapped down with the magnets, here's an example of what it looks like just in its natural state from the far left position swung over to the far right position through an arc that's pivoting about the center up there. I have just a dovetail tool post here. Jerry Beal, who used to be active in the OTI, had this idea with, this is just a knob on the back that's pushing a plunger, so you drop your tool post or your tool holder on there, drops down, the height is set with the knurled nut on the normal tool holder, and then the plunger. This is like the piston style of a tool post, but it's just one face. I can make it half the width so that I can get the tool onto as close to as possible the center line of the overall slide rest as possible. And of course, because it's a spherical slide rest, you're not limited to just working across the piece. You can, put the pivot back here under the extensions and swing across the end of the piece. Obviously, you never need to go past center, but depending on what kind of cut you're making and what you're trying to accomplish, because it's magnets and you can put it anywhere on the table and you can slide the table in and out. You can have your cake and eat it too. So now, just to make it obvious, if it wasn't already, what the visualizer does, here's our piece, our blank mounted on the lathe. Here's a close-up of the magnetic clamps with the hole between them and then the post jammed in there. It's just a slip fit. It doesn't have to be accurate because you're going to eyeball all this anyway. And now I put the Perspex acrylic piece on top, and I'm looking straight down through it. And what I've done is I used the hole as a pivot on my milling machine, and I just milled a series of arcs 1/4 inch apart until I got to a certain distance and then expanded them. And now you can just see right through this and see exactly what the shape is that you're going to cut if you've locked down the pivot right there. So it pretty much takes the guesswork out of it. I can see that's not the shape I wanted, any of those, so I just took the pivots, slid them farther down. I wanted a tighter curve on here, and I could just look right through there, pick the one I want. And as I'm feeding my tool in here, all the roughing cuts are just going to be out here until I sneak up on the final curve that I might want. When I took this up to Seattle, after I did the AAW, I flew up to Seattle, did I fly? Yeah, I can't even remember. Flew up to Seattle, and we had a play day with the old gang in Jon Mo's shop up in Seattle. And Robert Purdy, Bonnie's husband, as I'm doing all this stuff and explaining the reverse curve at the end, he says, well, why don't you just take a 1/4 out and put that on there, and then you can see where the cutting frame's going to go. So that looks like this. So now you can see the cut that I'm aiming for here is going to be along this arc, and it's going to return with roughly the diameter of my cutting frame head here. And so that's going to give me one of these gorse-like curves that's going to start here, come down, and have either the stem of the fruit or the bottom of the vase or however you want to think about it. And so that's what that looks like. Here you can see, sorry for the line, there's no way to focus on the lines and the workpiece, but you can see now this is a workpiece turned with the Sign 24 rosette. And here it is going here. Here's the edge of the 1/4, kind of mimicking that reverse curve. And then if we slide the visualizer out of the way, there's what that workpiece looks like that had that smooth curve and then the reverse that you get for free off the end of the cutting frame. And like I showed in the pieces that Gorse did earlier, you can have that curve at one end, the other end, both ends, whatever your design leads to. And it's really amazing. Once you kind of go through this, most people don't, everybody thinks curvilinear, I have to have a curvilinear, but there are so many millions of portions of arc, portions of sphere that you can get, and especially when you combine them with another reverse curve, the palette is just endless. But wait, that's not all. So, I have another bad habit or hobby or whatever you want to call it. I love decorative knots. Anybody in here tie knots? Anybody know what that is? Nope. Nope. It's related to Turk's heads, which coincidentally are exactly what a geometric chuck produces, but that's another story. This is called a sailor's knife lanyard knot, occasionally called a diamond knot. It's my favorite knot. It's on my business card. Anyway, in the bottom of this spherical slide rest out at this end, what I did was I just kind of, I cut a groove in here on the milling machine with a little reservoir for the knot to drop over a peg. So there's a peg here. The line then comes out and around and goes this way, comes out and around and goes this way. And out at the edge of the table, I just have a little clamp that slides along the edge of the table, and I have a stepper motor with a little spool on it, and I just put it on the slow speed, and it just goes tick, 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 and drags the thing across the arc. And to get the perfect tangent line that I was trying to get all the time by adjusting the all thread on that older version, all I have to do is move the clamp until it's on something that somewhat approximates a tangent, but the whole heel end of this slide rest is circular, so I can pretty much pull from any angle I want and still be pulling on a relative tangent to the whole slide rest. So, how did I do on time?
You're not speaking fast enough.
Are there questions?
You time
design your stepper motor to the speed of the cutter so that you get a good consistent cut all the way around?
Yeah, but it's, I mean, there's nothing magic to it. It's just, you know, the wood, the cutter I'm using. There's no coordinated motion here. This is just moving it slow enough that for the RPM that I'm comfortable for the wood I'm working with, I get a smooth cut. And that piece, the demo piece is on the spindle in there, so you can see how smooth it is, and that was a demo piece that I whizzed through.
Why did you make a slot for the magnets?
Why did I?
Make a slot for the magnets. You said on one of them that you had a slot on one side of the magnet.
Oh, no. Like in the bottom of the puck here?
Yes.
No, that's the way the installation instructions, these magnets are pretty brilliant. The installation for these is painless because on this particular one, it's a 30 millimeter hole. So you just drill a 30 millimeter hole, but the magnet itself is shaped like this, but the cover of the magnet, the upper part of the magnet, they designed their body to cover the 30 millimeter hole they made you drill, and then they put the mounting wings just outside of that, so those holes are drilled and tapped in the puck. Yep.
What do you use that gear you made for on
The gear that I made by the Rosette is I'm doing some stuff with some timing, with some stepper motors and programming coordinated motion for other things. And so that gives me a timing pulley on my headstock. And I chose 3/4 inch thick HDPE because it was easy to machine, but that's a drop-in replacement for the original MDF pulley that's on the back there. So basically you unbolt that, bolt that one on, and now you have, if you put a stepper motor on, you can have coordinated motion on, you know, anything you're doing. Celia?
John, you said something about you put a piece of steel over the bed of the Mark.
So
Are you using this spherical slide rest on the Mark?
I'm getting ready to. So all I wanted to do was, you know, I realized it's sort of like, I mean, you know, David solved the problem long ago with having a big cast iron table on the Lindau machine. But, you know, the Mark II has traditional bedways, and I just realized if I had a plate with a tenon on it that just dropped onto the bed of the Mark II that I could cinch up from below, now I've got a level plate that I can slide in the ways and mount anything on magnets anywhere. And I actually I sort of like the way I made the one for the MDF asymmetric. I kind of also have it kind of wrap around a little bit so it goes kind of past the edge of the headstock when it's close. But it's just the future is wide open, as they say. Any other questions? All right, that's good because I chucked in a couple extra slides in case I went fast enough and we didn't go over our time. Fred inspired me earlier, and somebody, I can't remember who was sitting behind me, maybe Bill Ohms at the time, and I heard some other chatter, but when Fred put up his lacquer box picture earlier today that he was going to mimic with his spherical slide rest and whizzy new cutting tool, there's I think that he's designated as a national treasure is the terminology. Kuroda Tatsuaki in Japan, he was the actual carver of that box, and his work is just, it's incredible. As I like to say, it gives me chicken skin, you know, just every time I see the quality and caliber of the work. And it was all done by hand. He died in 1982. The piece that Fred showed earlier was circa, like a couple I'm going to show here, 1957. And his work, although there's smatterings that you can find occasionally, there is one book that I've not been able to find. Fred has a copy. If anybody finds one, I'll pay you twice what you paid for to get it. He's just an incredible carver. And this book, which is a National Museum of Modern Art in Tokyo, put it out in 1983. And it's the only place that really, Oh, it's the only place I know of that collected almost all of the images of his work. And so here's a couple more boxes, in the vein of what Fred showed earlier, but they're organic, they're soft, they're continuous. I mean, I've never seen other work that just sort of epitomizes the design characteristic that he has in almost every one of his pieces. He did some ugly pieces too. But I mean, when you flip through that book, almost every one of them is just a design-inspiring piece. And I think if you're not familiar with his work, you should be, because it's just incredible stuff. And one of my other mentors, who is also no longer with us, hadn't ever heard of him either. And so when I sent a picture years ago to Paul Fletcher of not all of his pieces are round either. So this is a stationary box from 1957. It's one of my favorite pieces because it's so different. The design wraps around every surface. And when I sent this to Paul Fletcher, he immediately embarked on trying to duplicate it on his Holtz. And so here's the picture of the work in progress on Paul's lathe. And so I just thought that would be a good way to end the talk. Thank you.